Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to discuss what do you mean a graph. A graph is a group of vertices and edges that connect them vertices. That is basically graph consists of a group of vertices and edges. So how do we connect them is very important. You must remember we have learned about the linked list, stack, queue and different data structures where we followed kind of a binary tree also in which there was a parent child relationship, but in case of graph there is no parent child relationship. We have vertices and they are connected by the edges. Let us begin with the topic. A graph G can be defined as an ordered set. It is very important we have the ordered set. We represent it as G with the variables called as V, that is going to represent the set of vertices, and E where E represents the set of edges, where V of G is going to represent the set of vertices and E of G that is edges of the graph. So basically when we deal with the graph we are going to have the vertices and its edges. Vertices are going to be connected through the edges. Let us look at the different types of graph. There are basically two types of graph, directed graph and undirected graph. Let us begin with the undirected graph. We have a graph of 5 vertices, namely A, B, C, D, E. This is your undirected graph because in case of undirected graph, there is no particular direction from a vertices of one type to the vertex of another type. That is how to travel from one vertex to the another vertex. Their direction is not fixed. That is not given the direction. Hence the name undirected graph. Just the opposite of that is going to be a directed graph. It is very important. In case of directed graph, you have the direction set in which the vertices are to be connected. Let us look at the example. This is the example of undirected graph. But if I give the direction for A to D, as you can see, I have given the direction from A to D. So what it means that I can travel from A to D in this direction only in case of directed graph. Let us go for another set of value of direction graph. We have this. It means we can travel from D to B. Like this, we are going to connect all the 5 vertices one by one. These are this set of directed graph. Let us look how we can travel. Let us look if we want to travel from A coming back to A. What are the possibilities where I can go through? First, I will start with the vertex number A. Then I move to D. Then after coming to D, there are only one outgoing direction, that is from D to B. So I take the path D to B. Once I come to B, I need to reach to A. What are the two output directions? They are basically B to A and B to C. So I can travel from B to A and come back to A original. So our path of direction becomes A to D, D to B and B to A. Like this I can travel from A and come back to the A. Let us go for B. We have output direction in from B to C only and B to A. Let us go with the B to C direction. We have B to C, but coming to the C, we are not able to move out because both the nodes, that is both the edges, are coming inside directed and not going outside directed. That's the importance of directed graph. We can go from B to C, but we cannot go from C to B back. That is the directed graph. If it is for undirected graph, we can obviously move from B to C and C to B back. Since it's a directed graph, we cannot move back from C to B. So this path won't hold me the true. Let us go for another set of path. We have B to A. From A I can move to D, and from D I can again come back to B. So our path becomes B to A to D, and from D I can again come back to B. Now let us look at the C. Vertex C. From C there are two edges, but both the edges are incoming. There is no outgoing edges. So in this case, C can receive something, but it cannot give back. That is, there are only incoming edges to the C. There are no outgoing edges from the C. Let us go to the vertex number 4. That is your vertex number D. Let us go with the vertex number D. In vertex number D, there are two incoming edges and one outgoing edges. That is, from D, I can move to B. From B, I have two paths, B to C and B to A. As you can see diagrammatically, from C, there are no outgoing edges, there are only two incoming edges. So there is no use from going from B to C. I can then move from B to A. And from A, I can once again travel back to D. So our path becomes D to B, B to A to D. Let's put it in the paper. We have D to B, B to A, and again A to D. Now we will go with the vertex number last. That is vertex number 5, which is vertex number E. Let us go with the vertex number E. In E, we can go with the two path, E to C, E to D. As you can see, from vertex number C, we cannot move further because both the edges are incoming and there is no outgoing edge. So we don't go with the vertex number C. We move the path along D. So our path becomes E to D, D to B, B to C. But it cannot again come back to C. So this is also not done in case we once again want to reach to the same vertex. So these vertexes A, B and D have the cyclic path. That is, cyclic path is those paths in which once we start with that particular node, we can again reach back to that particular node. This is how you deal with the graphs. Basically, there are two types of graph, directed graph and undirected graph. In case of undirected graph, there is no direction given from one vertex to the another vertex. Just the opposite of undirected graph, the directed graph always has a direction how we are going to travel from one vertex to the another vertex. Thanks for watching this video. Please subscribe to Ekeeda channel.